Good day, everyone. Welcome back to this tutorial. In today's video, we're going to be looking at refraction of light. So, in our last video, we talked about reflection. So, a refraction of light is just the bending of light as it passes through two given media. That is, when light travels from one medium, like in this example, we have light traveling from medium of air to glass. So, if this is the incident ray traveling this way, then at this point of incident, it's going to bend downward this way. So, this medium this is a transparent uh, this thing. So light will be able to pass through it. But instead of the light to go straight, instead of the light to move straight this way, the light will bend at an angle. So we said this is the incident ray. This definitely I is the angle of incidence. So I is the angle of incidence. And R is the angle of diffraction. So then we have the laws of refraction, which state that the incident ray, the refracted ray, and the normal, they all lie on the same plane. So that's the first law. Then the second law says that the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. That is, sine I over sine R is a constant. So that's it. Now you might be asking, what is this constant? So that constant is what we refer to as refractive index. So refractive index is just the sine of I over sine R. Now, uh, according to the wave theory of light, it said that the refractive index from one medium, let's say from medium 1 to medium 2, is equal to the velocity of light in medium 1 all over velocity of light in medium 2. So that's another formula for the refractive index. That is, when light travels from medium 1 to medium 2, so the refractive index is given by velocity of light in the first medium over velocity of light in the second medium. Then uh, let's look at this now. Let's if we have a medium, let's say light is traveling from air into glass. Then this is the normal, this is the angle of incidence. We said this is I and this is R. Now note that the angle we are taking must be the angle between the incident ray and and the normal. That's I. Then the angle between the refracted ray and the normal is given by R. Now, according to the we said uh, from this, so this law is referred to as Snell's law, which is that's the name of the scientist that stated this, Snell. Wilfred Snell. So, if we have this now, instead that if you are traveling from air to glass, that is the refractive index from air to glass is equals to sine I all over sine light from air to glass. Now, according to the principle of reversibility of light, that states that if you have something like this, if you have light traveling this way, remember we did it under the law of reflection. So, if the light is reflected this way, so if I have light going this way and it's reflected this way, according to the principle of reversibility of light, if you take the source back to this place at the same angle, if it's uh, incidented this way, is going to reflected the other way. That is, the light ray will pass through the same line where you switch it. So the same thing happens to refraction. If this is our angle of incidence, if you take this as our angle of incidence, and this is the refracted ray, that is, light now is traveling from glass to air. We are going to have the refractive index from glass to air is equals to, now remember this is now our angle of incidence, which is sine r all over sine I. So that's the reversibility. So from here I can say A from air to glass, which is equal to sine I over sine R. Now if I do something like 1 all over sine I, uh, if I take this now, this can be given as from glass to air. You can see, if I take the inverse of this, it's going to give me sine I over sine R, then it will be the inverse of it. So that means from air to glass is something as 1 over from glass to air. So that's it. So that means if we have light traveling from medium x to y, I can simply say it's 1 over the refractive index from y to x. So that's another formula we have here. Then what if light is traveling from two or more into two or more media? Let's say we have something like this. And let's say this from air to glass. This is, let's call this glass. Then let's say this is water. And let's say this is air. That is, we have air here, we have glass here, water, then air. So if I draw the normal line, now the angle of incidence for air, let's call it IA. Now as light passes through this, it's going to be refracted this way. Let's call it RA. That's angle of refraction of air. So into glass. Now from glass, from this glass now, this is now angle of incidence on medium, on glass, which we call I glass. Then it will be refracted this way. So let's call the angle of refraction of glass RG. Now this will now become the angle of incidence on medium of water. So if I draw a normal, so this is angle of incidence of water. Then I'm going to be having angle of refraction. So it is refracted into that's angle of refraction into water this way. Yes. So from here now, I can take the refractive index from air to glass. Refractive index from air to glass is equal to, according to Snells Law, that's sine I A all over sine r a. Now, if you look clearly at this diagram, you will see that RA, that's angle of refraction of R. If you look at it, it is an alternate angle to IG. So that means this is the same thing as sine IA all over sine IG. Then again, from glass water boundary, we have from glass to water, we have sine Ig all over sine Rg. But if you look again, Rg is equals to Iw. So I can say this is sine Ig all over sine Iw. Then again, water back to air. I can say from water to air, this is sine to water, then sine I to, that's sine R, angle of refraction of water. So this will be the same. So if I continue this air boundary, so this will be the same thing as sine angle of incidence of water all over sine angle of incidence of air. So from here now you can see this is following a particular pattern. So from here, from this first line, we can have that the refractive index from air to glass times sine of incident of glass is equals to sine of incident of air, this way. Then from this line also, from glass to water, sine of incident of water is equals to, so what I'm doing here, I'm just cross multiplying, which is equals to sine of incident of glass. Then this also. Now we can also take the reverse of this. That is, if light is traveling in this way, that means from air to water. Now I can say from air to water is equals to sine. So from air to water, sine I of air all over sine R of A, which is same thing as sine I of A all over sine I of water. So this will give me, for this we have from water to air, sine sine I of air is equals to sine I water. Then this also, we have sine is equals to sine I of water is equals to sine of incident of air. Now from here, I can relate this and this, I think. So I can relate this and this together. Since we have this, look at this is equals to this. So I can say the refractive index from air to glass, sine of incident of glass is equals to. So in place of this now, I'll replace it with it, which is equals to refractive index from air to water, sine of incident of water. So if I now take the relative refractive index, that is, since the refractive index of air is 1, that is, if I take the refractive index, in which this one is 1, so I'm going to have the refractive index of glass sine of incidence of glass is equals to refractive index of water sine of incidence of water. So clearly now we cannot generalize this and say the refractive index times the sine of incidence, that's of a particular medium, is a constant. So what we mean by is a constant is that this can also be equal to refractive index of air, then sine of angle of incidence of air, which can also be refractive index of any material, sine of angle of incidence of that material. So we'll be using this formula to relate when you have light traveling from two or more media. So let's take an example and see. So a film of oil of refractive index 1.2 lies on water of refractive index 1.33. If light ray is incident at 40 degrees in the oil on the water boundary, evaluate the angle of refraction in water. So what we have here is uh, two given media, that is, from we have oil, we have water. Then light is incident at an angle of incident of 40 degrees in the oil on the water. So we are asked to calculate the evaluate the angle of refraction in water. That is, we are looking for this real. So there are two ways of doing this. The first method is this. To use this, we said light is traveling from oil. So refractive index of oil, so I'm going to use O for oil, then times sine of angle of incident of oil is equals to the refractive index of the other media, which is refractive index of water, times sine of angle of incident of water. But if you look at this now, we said the refractive, the sine of refraction, the sine of refraction of the first medium is equals to the sine of angle of incidence of the second medium. So you can see the angle of refraction of the first medium is equals to the angle of incidence of the second medium. So I can say, since this is the angle of incidence of the second medium, I can say this sine I of oil is equals to refractive index of the second medium. So in place of this now, it's going to be sine of R. That's R of oil. This is angle of refraction of oil. So the question says we should find angle of refraction. Okay, evaluate the angle of refraction in water. So angle of refraction in water is this R0, or simply let's just use R. So from here now we can look for R by saying sine R is equals to sine I all over n. So R is now equals to sine inverse of all over n. So if we plug in all the parameters given, so we are going to have R to be equals to sine inverse of n oil, that's refractive index. So oil of refractive index. So this is the refractive index of oil, which is 1.2, then times sine angle of incidence, that's 40 degrees, over the angle of, okay, that's refractive index of water, which is given as 1.33. So if we do this correctly, so if we do this correctly, we should be having 35.4 degrees. So that's the angle of refraction in water. So also we can alternate. That's also we can use another method to do this by saying, since the refractive index for these two given meter, that is from oil to water, is sine I over sine R. So that's according to Snells Law, which is sine 40 over sine R. But we are not given the refractive index from oil to water. What we are given here is this. We are given the refractive index from air to, since this is oil, that's like, if we bring back, since this we are using relative refractive index, which I said for air it is 1. So if we bring back that now, we have from air to oil, which we are given to be 1.2. Then we are given from air to water, which is 1.33. But here we need oil to water. So recall when we said if we have refractive index from A to B is same thing as 1 all over refractive index from B to A. So we are going to use this relation now. So I can say refractive index from oil to water is same thing as. Now, how do we come about this? We can say this is equals to refractive index of oil to air times refractive index from air to water. Okay, this is another relation which you can use. If you have refractive index from medium 1 to medium 2, it's same thing as refractive index from medium 1 to 3 times refractive index from medium 3 to 1. So we can always use this relation. But if you look again, we don't have refractive index from oil to air, but we have air to water. So I can convert this now. This is what we are given. So this is same thing as 1 all over refractive index from air to water using this relation times refractive index from air to water. So from here now, I can say refractive index from oil to water is equals to refractive index from air to water over refractive index from air to oil. So what is saying that refractive index, so this another relation, that is refractive index from medium 1 to medium 2. If you have refractive index from medium 1 to medium 2, is same thing as refractive index from medium 2 over refractive index of medium 1. So you can also always use this relation. So from here now, we can now find this by saying this is from oil to water is equals to refractive index from air to water, which is 1.33 over 1.2. So which is equal to, so let's leave this way so that we'll not be approximating any value. So if I take this and plug it into here, which is equals to sine 40 over sine r. So I can make r the standard formula by saying r is equals to sine inverse of sine inverse of 1.2 times sine 40 over 1.33. So you can see we've come back to this. So if you do this correctly, you should have the same answer. So that's the second method we can use to solve questions related to refractive index. So let's take another question. Let's take another question. So a ray of light travels from air into water at an angle of 70 degrees with the surface. The index of refraction of water is 1.33. Calculate the angle of refraction. That's the first question. And the second question is the speed of light in the water. So now a ray of light travels from air into water. So we have this to water at an angle of 70 degrees with the surface. Now, this you have to be very careful with the surface, not with the normal. So the light travels this way with the surface that is 70 degrees with the surface. Then, so this angle, though this is perpendicular, so the angle of incident, that's I right here, should be 20 degrees. So we have to calculate the angle of refraction. So if the index of refraction of water is 1.33, so this now we are going to use the uh, relative refractive index. That's what we are doing. Say the refractive index of air is 1, so to that of water. So we can say the refractive index is equal to sine I over sine R. That's according to Snells Law. So 1.33 is equals to sine. So angle of incident, that's 20 over sine R. So we can have R to the sine inverse of sine 20 over 1.33. So this gives R is 14.9 degrees. So that's approximately 14 degrees. Now the second part says calculate the speed of light in the water. So remember from the first part of from the beginning of the lecture, we said refractive index is equals to sine of sorry is equals to velocity or speed velocity of light in the first media which you have is what in air over velocity of light in water. So if we make this the solid formula, we can say instead of velocity we can use speed. So speed of light in water is now equals to velocity. That's, let me use speed. Speed of light in air all over the refractive index. And the speed of light in air is 3 times 10 raised to 8 meter per second, which we are given here. Then over the refractive index, which is given as n is 1.3. So we do this now. So we'll be having the speed of light to be equals to 2.3 2.25 times 10 raised power 8 meter per second. So this is the speed of light in water. So I think we're going to end the video here now. So thanks for watching. See you next time. Make sure to like, subscribe, and subscribe to this channel. Also, make sure you share the video to your friends. So see you next time.